Welcome to Callous Coder, and today we will be exploring whether I modulo 2 equals 0 needs to go in favor for I logical AND 1. Motherfucker! We all have been there, we all have done it. If I modulo 2 equals 0, then return light gray, else return dark gray to alternate the colors in a table, for example. My position has always been that using a modulo for that is far too expensive. Other colleagues argued, rightly so, that my approach of using a logical AND is not as legible. And there is a point to be made for that as well. But let's settle this once and for all. The gloves are off, let's dive into the code. I created 3 versions of the same program, a C++ version, a Java version and a Python version. Not to compare these languages among each other, even though that's a nice benefit, but to see how they behave differently. The C++ program looks like this, and I purposely made this an integer because in my idea an int is a signed variable, so it would compile down to an IDIF, assuming that the compiler is not optimizing. And that is the big assumption that I make, that even the compiler will probably go from this to that. But let's see that. And here we have the logical AND version. They basically do the same thing, except my position is that this is far faster than that. I run this iteration, I do it 10 million times for each. I will do that 100 times. I take each run and put it in a list, so we can at the end average that list and have an average time, because if you only do it once, there could be some weird interactions of the operating system in there, and etc. So now we consolidate it to a nice average. So let's run this and see what it turns out to. This is an optimized binary, by the way. Ready? That went way faster than I expected. Okay, so 1200 microseconds in both cases, 1264 microseconds, 1240 microseconds. Well, in all ways you look at it, these are pretty much the same, right? And I think that my position is warranted, that a clever compiler will compile the modulo down to a logical AND operation. So let's check this out. GDB. This assemble AND method. Let's use my reference first because I know what I'm looking for then. Again, I find my AND operation here. Yes, there it is. It is using a logical AND 1. And then compare that. Yeah, that is the instruction. Okay. Now let's look at this assemble modulo method. And since these averages are pretty much identical, I think this will also use the same approach. Here we push the arguments on the stack. It uses the same parallel add as we saw before. And here the same thing. Exactly the same code. Exactly the same code. So the GNU compiler is clever enough to convert an expensive modulo operation, when it's modulo 2, to a logical AND. So I take this win, to be honest. A logical AND is faster. Let's run the Java class. Let's first have a look at the Java. And it's, well, in all intents and purposes, it's exactly the same as the C++ application. Yeah, it's a bit slower than the optimized C++, which we would expect about 5 times. But also here, 100 microseconds, that is negligible. So also here we can conclude that it doesn't make any difference. I assume that the Java compiler will turn also the modulo into a logical AND. It's clever enough for that. Those people at Sun were smart cookies. Yeah, that's not really different. Okay. Now Python. Let's see in an interpreted language. Let's first look at the code. Again, in all intents and purposes, it's exactly the same. Except here we run it 3 times, so let's change it to 100. It's gonna be a long while. I'm pretty sure it's gonna be a long while. I tested it with 3 and it took forever. Okay, let's look at the numbers. Well, that is a significant win. That's about 300 milliseconds for each run. Wow, that is significant. Let's run it again to see if this was a fluke or not. Where were the good old days that people actually used Fortran and C++, right? Okay, let's look at the numbers. It's again 0.3 seconds. Wow. Well, the numbers are in, so ready to make a conclusion. Well, the conclusion is pretty obvious. When you're using compilers these days, it doesn't really matter if you use I modulo 2 or I logical AND 1. Compilers are smart enough to optimize your code for your situation, even Java. However, with interpreted languages, these sort of decisions still are important. And I'm trying to get the concept across to think about these things when you're developing and make the safe choice. Readability is important, but speed, especially in slower languages, is also very important. And you be the judge for your situation, but just be aware that there is a significant difference. I hope you like this one and see you in the next one.